Alright, we're back again. We're looking at solving the right angle triangle, but in this case, we intend to find angles. What if we're given both sides? For example, this angle here, we don't know what it is, but we realize that this is 3 meters, and let us say this is, I don't know, 7 meters. We intend to find what angle it is in a right angle such that this will be 3 and this will be 7. The principle remains the same, that we can utilize the trig ratios to help us out. Alright, the trig ratios. So surrounding the sine, which is the opposite, over the hypotenuse, cosine, which is adjacent, over the hypotenuse, and the tangent, which is the opposite, over the adjacent. In this case, you're seeing that for this angle, we have 3, which is the adjacent, and we have 7, which is the hypotenuse. Adjacent and hypotenuse is the cosine rule. So let's write it down. The cosine of an angle, is equal to the adjacent side divided by the hypotenuse side. So the cosine of the angle that we don't know is equal to the adjacent, which is 3, divided by 7. Well, it's up to us. We could find a value for that, just to look at it. So let us look. So the cosine of the angle is going to equal to 3 divided by 7. Is 0.4286. Alright? So to 4dp, the cosine of the angle that we're looking for is 0.4286. Well, how do we solve this? We need to use our calculators to get the inverse of this. So we are finding the cosine inverse of 0.4286, and it's going to give us that angle. So on our calculators, we could use the inverse. So we are looking for the inverse, the cosine 0.4286, and the angle to 1 dp is 64.6 degrees. So that's the angle here. The angle here is 64.60 degrees for that angle there. So there, as you can see, we utilize the cosine rule based on the situation to find the angle there. Alright, what we could do here, we could try to find this angle too, to see if what we did was correct, right? What could this angle be? So I'm going to call this angle alpha. Now already we would have an idea that if this is 64, then yes, that angle is going to be 90 minus 64.6. So we're looking for 25.4 as that angle. But let us just see if this works out. Alright, same situation. We're saying that, what is this angle? Alright, now already we know what this angle is. So we're just going to use our trig rules just to prove. So this is 64.6. Remember, we rounded off this, but we want to test our thing here to see. So this is alpha, right? So we want to find this angle where we have the opposite and we have the hypotenuse. It's sine. So we're going to be using the sine rule. The sine of an angle is equal to the opposite side divided by the hypotenuse side. Well, let's look. Sine of this angle is equal to the opposite side, which is the 3, divided by the, which is 7, the hypotenuse, which is 7. So what are we looking at? We're looking at the sine of the angle. The sine of the angle is 0.4286. What? 0.4286. So therefore, the inverse sine of 0.4286 should give us this angle that we're looking for up there. That's the angle we're looking for. We're looking for angle, angle theta. Well, I should have probably put this here so that we are on that same page. Let me put them back. All right, sorry about that. So we're looking for the angle alpha up there. So if we use sine inverse 0.4286, you'll see that we get 25.4, which is alpha. And we did say we are expecting to get that, because if this is 64.4, then this is going to be about 25.4, and you would work that out to see that yes, it is correct. All right, so there it is. If we have two sides and we are asked to find an angle in the right angle triangle, we still can utilize this, the SOHCAHTOA, the trig ratios, and sort out the problems. All right.